In this video, we're going to be writing the code for our single stick tank controls, meaning we're only going to be using the right stick on the controller in order to make our robot go forward, backwards, or turn. Now the code we're using is going to be quite similar to that you'd see in video games, or if those of you who are familiar with Vex Robotics, the single stick tank controls available for that. There are some minor changes we have to do to it in order to get it to work with our current motor controller system. Before we begin all that though, I'm going to point out a mistake I made on the previous video. So right here in our if statement, we're checking for an equality between these two values. I've overlooked something though with this check for equality. Even though our switches should only be returning ones and zeros, they're still returning some range of numbers between 1000 and 2000. So the switches don't quite work the way you would expect a switch to work. We basically need to make the check look to see if one of these two values are greater than 0.9 and the other one is less than 0.1. It's going to be a bit of a mess, but we'll get through this. So the first thing I'm going to do is I'm going to detach this block and just toss it right up here for now. Then I'm going to come over here to logic, and I want to grab this right here. So the AND right here, whenever we put this into a logic gate, this is going to mean that both this element needs to be true and this element needs to be true. So there's going to be a truth check here and a truth check here. If we change this to OR, if either one of these two things are true, we do what's in the do. If neither of them are true, we do what's in the else. So with AND, both of them have to be true to go into the do. With OR, either one of them can be true to go into the do. Yeah. I believe OR is what we're going to want to do. I'm going to come over here to logic again. I'm going to grab our comparison here, drop it right in here. And what we're going to look for is less than. You know what? I don't want to put the OR in here yet because I want an OR here, but I also want to check to see if two things are true. So I'm going to drop this AND right there, and now drop this here. So what we're going to do is we're going to look to see if our input value 4 is less than, let's grab a number here, 0.1. That's a pretty big range for it to be looking for it to be less than, but it at least eliminates the possibility of the switch being up. But this will show true for anything where the switch is in the down position. So we're going to duplicate this, put that right there. Instead of value 4, we're looking for value 5. Let's drag this over here so we got more space. So now, if input value 4 and input value 5 is less than 0.1, we'll get a true response, meaning we do our nothing that's in our do category. I'm going to copy this, snap that in right there. So now this is insanely long. I'm going to change this to greater than on both and change it from 0.1 to 0.9. So now if if both of these are greater than 0.9, this is going to come back as true. And again, because it's in our OR, we go into this section right here. So it's no longer checking to see if both values are true. It's just checking to see, if both values are equal, it's just checking to see if both values are in the same range as each other. If they are in the same range, that means both switches are in the same position and our code shouldn't be doing anything. That fixes our kill switch there. Sorry about that mistake in the other video. So let's move on to the drive code now. Taking a look at our drive code right here, I'm just going to position this right here. And First thing I want to do is I want to make a couple of variables. Now these variables I'm making, I want them to be number type variables, and they're going to be storing how fast each side of wheels should be going. So this first one I'm going to call left wheels. I'm going to create another variable, and we're going to call it right wheels. There we go. I'm just going to drag one of these sets in here. So it doesn't matter whether you start with left or right wheels. I'm going to start with left wheels simply though, because that's how I had it written in my test code. So we got set left wheels, going to duplicate that, set right wheels. And this is where we're going to do our start of setting our wheel speeds. Now, one of the problems with doing tank controls with a single stick is when you're looking at a tank in real life, the person driving it, they have two sticks. One stick they push forward and pull back, controls the right side will control the right side. The other stick will control the left side. So whenever it comes to turning, depending on how fast they want to turn, they would, if they just wanted to do a on-the-spot turn, they would pull the left stick all the way back and put the right stick all the way forward. We can't duplicate that accurately with a single stick unless we do a little trick with the code. And before we proceed, I'm going to point out that I goofed the other day when I was talking to you about which axis is horizontal and which axis is vertical. Axis 0 is the horizontal for the right stick, and axis 1 is vertical for the right stick. Sorry about that. So what we're going to do now is we're going to click on the math function here. We're going to drag this in. We're going to put that right there. Let's just go ahead and copy our get axis from here. Drop it in there, and we're going to set that to axis 1 because we want our forward back. Duplicate that, put that there, and change that to 0. So what this is going to do, it's going to take both of these values and it's going to add them together in order to determine how much the left wheel should be spinning. If our stick is being pushed forward all the way, this is going to come back as a 1. If it's pushed all the way to the right, this is going to come back as a 1. If it's pushed all the way to the left, this is going to come back as a negative 1. The reason why we want this to come back as a 1 when it's pushed all the way to the right is when we're turning our vehicle, the outside wheel needs to be turning faster in order for us to turn in a given direction. All right, so after this, we're going to go ahead and duplicate this. And it's very important here that when we duplicate this, we're going to change this sign here to subtraction. So then what this is going to do, if we're moving forward and we want to turn right, this number, our stick's going to be all the way to the right. This number is going to be a positive number. So we're going to get back a 0 here, making our inside wheels basically stop. If we're turning left, we'd be subtracting a negative number, which would make this +1 instead, which will make our right side wheels go as fast as possible. All right, so the next step in our code here, we now have the possibility of values extending past the valid range because our valid range is only -1 to 1. So we need to renormalize our values or remap them down so that they fit within that -1 to 1 range. Because like I said, if we're turning to the right and we're going forward, our left wheel is going to return a value of 2. So because 1 + 1, 2. So let's grab our if function here. First thing we're going to do is we're going to check to see, are we outside of our valid range? So come up to logic. There are two ways we can be outside of the valid range. It can be either over 1 or under -1. So we're going to drag our, whoops, that's the wrong thing. Sorry about that. Drag that there, change this to or. because we need to be able to fix it if it's either one. And now we're going to come up here to set variables. So let's create a new variable here. Not entirely needed, but it does make stuff easier for me. Just going to call this normie. This variable is just going to be a placeholder for our normalization process. Drag this, put it right there. And I need to do our truth check first. Sorry about that. So let's just go ahead and grab one of these. Let's grab this truth check. Put that right there. So if axis, let's see. You know what? I don't want the input value here. I want to grab our left wheel value, current left wheel value. So we're going to go to variables, drag this, set it into that spot, hit the pull down and change it to left wheels. And we're looking to see if that is greater than 1. And we duplicate that. And we look to see if it is less than -1. So if it's outside of our valid range, we need to do something, right? So what we need to do is we need to figure out how much of a normalization value we need to apply towards our current value. Normalization value being a multiplier that when we multiply our current value by this multiplier, it's going to reduce it back down to that -1 to 1 range. And because this value is going to be greater than 1, because of how the math works up here, only the right wheels or the left wheels can be greater than 1 or less than -1 at a given moment. It can't be both of them. So at the end result, whatever our normalization value is right here, our factor right here is, it's going to make our rate value that is outside of the range pulled back to 1 or -1. The way we do that is we're going to put a little math function in here. It's going to be division. Here we go. Change that to division. And we're going to divide 1. Let's just grab the 1 from there. By the absolute value of our left wheels. So math. Drag this in right here, change to absolute value. Going to grab our get left wheels here and plug it in right there. So our normalization value is going to be 1 divided by the absolute value of left wheels. So if left wheels happens to be 2, 1 divided by 2 is going to return back 0.5. 2 times 0.5 is 1. I know that's fairly basic math, but that relation there is going to be used for setting both of our wheels so that they are both within the range and that we're scaling them both equally as opposed to having to do all the fun math to determine how fast each wheel should be turning. Yeah. So after that, we're just going to duplicate this right here. We don't want this to be set normally. We want that to be left wheels. Sorry about that. I'm going to change this to right wheels. In this one, I'm going to delete that. Delete that. What we want to do here is we want to multiply our current right wheel value by whatever our normalization value is. I just changed that away from normie. That's supposed to stay normie. Sorry about that. So what we're going to do is we're going to go to variables. We're going to grab our variables thing object here, our block, change it to right wheels, go back up to variables, grab normie, multiply that. So this value right here is already within our range, but again, we need to scale it by the same relative amount that we scale our left wheel with. So we've got that set there. So now we're going to come back up here, set variables. I'm going to change this to left wheels. And for left wheels, we are going to do first, actually, we don't even have to do a multiplication. Like I said, we know it's going to be 1 or -1. Let's just do the multiplication by the normalization value. So yeah, let's duplicate and that. That will normalize both of our, that will normalize our left wheels so that they are within the proper range. We need to right click on this block right here, duplicate it, get the whole if, because we want basically the same thing, but we're going to switch all the left wheels to right wheels and all the right wheels to left wheels. So if it's the right wheels that are outside the range, it fixes the right wheels so that it's inside the range. And if it's, adjusted left wheels appropriately. So these two little blocks of code, again, these are just for normalizing our values back to that -1 to 1 range. So what we need to do now is go ahead and set up our code to detect to know which way the wheel is supposed to be spinning and tell the motors to spin at the speed we want them to. So what I'm going to do now is come back up here to logic. I'm going to drag a logic gate in here, an if function. Then I'm going to drag my comparison over here. So if I go to logic, snap that in there, we're going to look at our left wheel variable. So I'm going to drag that variables thing right there, change it to left wheels. What we want to do is check to see if it is spinning, if it's supposed to be spinning forward or backwards. So where this equal sign is, if we change this to less than, let's go with less than. I'm going to grab our number values from math. So less than 0. So if our left wheel's number is less than 0, then this motor is supposed to be spinning backwards. And I grabbed the wrong logic function again. So let's kill that one out of there, select logic. We want if do else. There we go. So if this statement is true, what we want to do is we want to go ahead and set our motor to spin backwards. So we're going to come over here to DC motor, grab this block right here that says LM298N move, and put it in the do section. The way I have things wired, motor B is the left side. We want to switch this to backward because again, this left wheel's value is less than 0 if we're in the do section. Now we're going to take math. We want to do some multiplication. So we can snap that in there, change that to multiply, and we're going to grab the left wheel's value. Throw that in right there. Go back to math, grab a number block, drop it in right there. And with these motors, the maximum value you can put in and the motor still spin is going to be 255. So we want to put our max right here. This doesn't mean that the wheel is going to be spinning at 255 because this left wheel's number is going to be less than 1. And I forgot this one needs to be absolute. So I'm going to grab this, drag this block in, snap my next left wheels to it. Oops, there we go. Snap it back into place and change that to absolute value because this number has to be a positive value. Our valid values for this is anything between 0 and 255. So that's why we set it backwards here, and then 255 here where it's a positive number. This is still backwards. Absolute value of this negative number is going to give us a number between 0 and 1. If this number happens to be 0.5, if the left wheel's number happens to be negative 0.5, then our value after doing this multiplication would be 127.5, I think. Should be. Anyways, so this is going to tell our motor to move based off of what the stick is pointing at. Now we're going to duplicate this, snap it in right there. I'm going to change that to forward. Now we can change it to not have the absolute there, or we can just leave the absolute there because we duplicated, because the absolute value of a positive number is still a positive number. It just doesn't change. So then on this else section here, if left wheels is not less than 0, that means our wheel should be spinning forward. That's why I changed that there. After that, we're going to duplicate this. Oops, did not mean to grab that. To grab that, snap it in place right underneath that. And we're going to change everywhere it says left wheels to right wheels. And that does it. That creates your movement controls for your robot. After this, it will be wiring the robot together. Thank you.